another problem that we'll solve, which we have solved of a similar type in the very first problem in this tutorial video, but this is for a hexagonal lamina. So this is a hexagonal lamina of 25 mm side, and I've just taken all these data and listed down here. Now the hexagon is resting on one of its side on HP. The side is on HP, we need to draw the plane figure on HP. The other way around, if you want to identify where to rest the lamina, whether on VP or HP, see where the lamina is inclined to. The lamina is inclined to HP at 60 degrees. So it is clear we need to draw the hexagon in the top view. Now while you are drawing hexagon, you need to check one more thing, that is whether you want to draw it in corner condition or you want it in edge condition. Since it is resting on side, let us keep the side on the left side, which means that you need the edge condition. And that will give us the hexagon, but we want the side to be on the left side, but what we have here is the corner. So let us rotate this hexagon, rotate it in such a way that the edge comes on the left side, and the angle of this edge, which means that it should be perfectly vertical, the angle should be 90 degrees. You can move and keep it neatly. Draw projection lines from every point to the front view to get the front view of the lamina. Take a dark line. Instead of drawing one complete line, draw two lines. In between we have B and E. So we'll draw one line till here and the next line to the end. That completes the first position. In the second position, see the condition given with respect to HP, because we have drawn the plane figure on HP. So the lamina makes 60 degrees to HP. Angle HP, you draw it in the vertical plane. Right now it is at 0 degrees. The lamina is looking like a line and it is at 0 degrees. We'll incline this line at 60 degrees in the next position, the corner point or any end point of that particular line. And while rotating also, the first point you select will be fixed. So we are always choosing the left side. So make that as a fixed one and give an angle of 60 degrees. Draw projection lines from all of these points to the top view. Now for the third position, if you have a look at the question, we need to take the condition with VP. Because the condition with HP is already done, we'll take the condition with VP. It says that the side opposite to the side on which it rests is on VP. On VP in the sense we have solved already a problem of similar kind where it will be at 0 mm from the XY line. So this lamina is actually resting on the side that is on the left, that is A dash F dash. In the top view it is AF. So opposite to AF is CD. So the question says this side CD is on VP. Condition VP we need to satisfy it in HP. So we just need to make this point C and D to lie on the XY line. Here we can use this move command. And then we can rotate it. But remember, none of the names of this top view should go above the XY line. So C and D have gone above, we can just move it to below the XY line. So now by drawing projection lines from A to A dash and continuously, we'll get the final position. Join all these 6 points with a dark line and that will complete the solution. So this is another hexagon problem which is having a side of 30 mm and it is lying in such a way that one of the side touches both the reference planes. If the side opposite to the side on which it rests is 45 mm above HP, let us draw the projections for these conditions. I have listed down the data, whatever we read just now in the question. So first thing is we need to draw a hexagon of 30 mm side. But in the first position, the question you need to ask is where to draw the plane figure, whether on VP or on HP. So we have discussed in the previous problems, we will be able to identify that based on what the lamina is resting on. If it is side, we could draw the side on the left, and if it is side on HP, we could draw the plane figure on HP. But here we don't find any such conditions given with respect to side or corner. Instead, it says that one of the sides touches both the reference plane. So when we say both the reference plane, it means both VP as well as HP. So this side, one of the side is resting on both the planes. Now when it is given with respect to both the planes, we can't decide whether to draw it on VP or on HP. So this condition is not useful at the moment for deciding where to draw the plane figure. So let us read the next condition. You see here, the side opposite to the side on which it rests is 45 mm above HP. This condition is with respect to HP and hence we can draw the plane figure on HP itself. So since it is saying one of its side touches both reference plane, we'll decide this problem is to be with side or edge condition. So now we are drawing this plane figure on horizontal plane, which means that the condition of one of its side touches both reference plane, that is VP and HP, out of which if I draw the hexagon in the horizontal plane, that will satisfy the condition of one of its side on HP. So we will be only left out with one of its side on VP. So let us first position such that the side is on the left and we are drawing the plane figure on the horizontal plane. So now we need to draw a hexagon of 30 mm side and we need to ask the question where to draw the plane figure, whether on VP or on HP. It says that one of its side touches both the reference plane. So if it is given both the reference plane, we still have a confusion where to draw this plane figure. So if you are not able to get the solution for the first position using this first statement, you can go on reading with the second statement. The second statement says the side opposite to the side on which it rests is 45 mm above HP. Usually in many of the problems we will find the angle given with respect to HP, that is a lamina inclination. But this is a problem where instead of angle they have given the height at which the edge is going to be lifted up, which is 45 mm above HP. So we'll satisfy this condition later, but using this condition we can decide that we need to draw the hexagon on the horizontal plane, and it says that it is resting on one of its side. So we need to draw the hexagon with edge condition. So take a line with 0.7 mm width, give the distance as 30 mm and angle as 0. Again 30, the angle for hexagon that you need to use here in the computer is 60 degrees. So again length is 30, angle is 60 into 2. And hence we'll get the hexagon. You can just place it properly, but before that we see that it is resting on one of its side. So on the left you must have a side, but here in this position what we draw, we'll get a corner. So in order to get the side, we can select this particular hexagon and rotate it so that the edge comes on the left. You must be sure that this edge is inclined at 90 degrees to the XY line, means it should be perfectly vertical. So it is vertical. Use projection lines to generate the front view from here. And that completes the first position. So if you just look at the given data, we have drawn the plane figure on horizontal plane. So take the condition with HP first and implement it in the solution. It says that the side opposite to the side on which it rests is 45 mm above HP. Read it slowly. The side opposite to the side on which it rests. So according to this sketch, the left edge is AF. You need to take the side which is opposite to the resting side. So opposite to AF is going to be CD. So this CD has to be lifted up at a height of 45 mm above HP. Any dimension or condition given with HP will be drawing that in the vertical plane. So here right now this opposite edge, that is CD, is on the XY line. In the next position we have to rotate this whole lamina so that this C dash D dash is lifted up to a height of 45 millimeters. In many of the problems which you have solved in the previous cases, you will find the angle given directly. In the other way around, the condition can be given like this. Instead of giving the angle for the lamina, the question can be given like this as well. So we'll draw a 45 mm line above the XY line. You can use a command called offset, which creates parallel lines. You can click on the XY line, select the third line type for the locus line and a thin line. The distance should be given as 45 millimeters. So now we have got a locus at a height of 45 millimeters in the vertical plane. So now this plane, which is looking like a line in the front view, has to be inclined so that C dash D dash touches the 45 mm locus and A dash F dash should still rest on the XY line, which we can do that by using the move command. Copy this front view as it is to the next position. Now before inclining it, if you try to rotate it directly, this point C dash D dash will not rest on the locus exactly. If you want to get that exact point, you need to draw an arc first with projection line from A dash to C dash. You can draw an arc so that that arc intersects the locus. So now it is clear this C dash D dash should rest on this intersection. Now we can use the command of rotate. Select A dash first and C dash next. Place it at this intersection, so that even when you zoom it, the point C dash D dash should rest exactly on that locus at that intersection. So here, instead of the angle, they have given the height in the question. So we can identify the angle as 60 degrees. Nevertheless, angle is of no importance here because they have not asked you to find it out. Now we can use the projection line to get the second position top view. Join the 6 points to get the top view in the second position. Now we actually have one more condition left with respect to VP, because the question says one of its side touches both reference plane. So the side that we have chosen is the one that is on the left, that is AF. But there is one more condition that is left out, which says that one of its side touches VP as well. So HP condition is satisfied, only VP condition is left. Choose the same side that is resting on HP, that is the left side. Choose that side AF and make it rest on the XY line. You can use move command, first copy and paste this. So A is here on the XY line. Use the command rotate. Select point A first, F second, and rotate it so that the points A and F rest on the XY line. No name of horizontal plane should go above the XY line, so you can just cut and paste this A and F to below the line. So now we have rested this edge AF on the XY line itself. You can use projection lines to complete the final position from here. So from A to A dash, the same point will be A dash. You can draw from B to B dash. F to F dash will be the same point. You can name the points first. Join all these 6 points with a dark line to get the final position. That gives the solution for this particular problem. In many of the solution books, you will find the same problem for this question. You will find the solution with a side view. The problem can be solved with a side view, or you can draw it in this way as well. Whichever method is convenient and easy to you, you can follow that particular method. For doubts or clarifications, you can drop a comment or contact me through my mail ID